Hello everyone. This tutorial is going to be about the fundamentals of electricity and series circuits. I'm going to try to take it slow. There's a lot to grasp. Uh, we'll begin with some of the formulas for uh, variables of electricity. We'll start with Ohm's law. I use two pie charts, and I don't like to use some of the other variations, and the reason why is because it requires the students to have to remember too many letters, and it gets confusing. I just don't like doing that. The two pie charts that I use are Ohm's law and Watt's law. And by the way, uh, please zoom the video if you haven't done so already. Put it at full screen. Let's start with the Ohm's law pie chart. That's the one on the left here. And Ohm's law states that E equals IR. And let me go over what we're talking about when we're talking about E, I, and R. E is the symbol for voltage, okay? The base unit for voltage, and I don't want you to get confused, so let's go back up top here. The definition of the base unit. That's a unit of measurement. So anytime I'm referring to a base unit, I'm talking about a unit of measurement. How do we measure what we're talking about, this variable? We're talking about voltage. And again, the symbol is E. And I want you to remember this. I think the reason why we use the E symbol for voltage is because it stands for electromotive force. And that's the easiest way I can get you to understand and remember what E is. It's electromotive force. That's what voltage is. All right, we measure voltage in volts. That's the base unit. The symbol for volts is different. We don't use E for volts, the base unit. We use the symbol V, capital V. And I should note that all of these letters are capitalized unless I say otherwise. Okay, let's move down to the next symbol. The next symbol is the symbol for current. And the symbol for current is I, and it's measured in amps. The symbol for amps is A. That makes sense. Now, how can you remember what the symbol for current is? Well, I'll write that down. I is the intensity of electron flow. That's what I is. I is the intensity of electron flow. Now we come down to resistance. R is the symbol for resistance. And the base unit for resistance is ohms. We measure resistance in ohms. And the symbol for ohms is this strange looking, kind of like an upside down U. And this is the Greek letter omega. That's the symbol we use for ohms. So we measure resistance in ohms. Next we have P for power. And the symbol for power is P. The base unit is watts. That's what we measure power in. And the symbol for watts is W. I don't think any further clarification is necessary for power. I have 2 pie charts up here, and I want to go over the formulas with you. First, we'll deal with Ohm's law. And with Ohm's law, we have this pie chart, EIR. And if you can remember ear, then you'll always get it right. E is the symbol for voltage. Voltage equals I, the symbol for current, times R, resistance. So voltage equals current times the resistance. The second development of the formula would be an inversion, and that would be the current equals the voltage divided by the resistance. So if I'm given the voltage and the resistance, I can solve for I, the current. The third variation of the formula is R, resistance equals the voltage divided by the current. So if I know the voltage and if I know the current, I can solve for the resistance. The second pie chart I want to look at is what I call Watt's law. This is an easy formula to remember because it is a pie chart in that it uses the letters P-I-E. It's a true pie chart, so it's easy to remember. P in this case stands for power. Power equals the intensity times the electron flow, or electromotive force, I should say. In other words, power equals current times voltage. The second variation of the formula is current equals power divided by the voltage. And if I know the power and the current, I can solve for the voltage. Voltage equals the power divided by the current.